Yo, what's up, YouTube? It's your boy Isma. I'm coming back to you with another YouTube video of what is networking. The room itself is called Networking Fundamentals. A little introduction, begin learning the fundamentals of computer networking in the bite-sized and interactive module. Moving on to task 1. What is networking? Networks are simply things connected. For example, your friendship circle, you are all connected because of similar interests, hobbies, skills, and sorts. Networks can be found in all walks of life. A city's public transportation system, infrastructure such as the national power grid for electricity, meeting and greeting your neighbors, postal systems for sending letters and parcels. But more specifically in computing networking, it's the same idea, just dispersed to technological devices. Take your phone as an example. The reason that you have it is to access things. We'll cover how these devices communicate with each other in the rules that follow. In computing, a network can be formed by anywhere from 2 devices to billions. These devices include everything from your laptop and phone to security cameras, traffic lights, and even farming. Networks are integrated into our everyday life, be gathering data for the weather, delivering electricity to homes, or even determining who has the right of way at a road. Because networks are so embedded in the modern day networking, it's essential to concept to grasp in cybersecurity. Take the diagram below as an example. Alice, Bob, Jim have formed their network. We'll come on to this bit later on. And you have a picture of Alice, Jim, Bob in a network. Network comes in all shapes and sizes, which something that we will also come on to discuss throughout this module. For the answer question below, what is the key term for the device that are connected together? And that is network. And you are ready to move on to the next module. Moving on to task 2. What is the internet? Now that we've learned what a network is and how one is defined in computing, just devices connected, let's explore the internet. The internet is one giant network that consists of many small networks within itself. Using our example from the previous task, let's now imagine that Alice made some new friends named Zion and Toby that she wants to introduce to Bob and Jim. The problem is that Alice is the only person who speaks the same language as Zion and Toby, so Alice will have to be the messenger. And you can see how she is connecting Zion and Toby to Bob and Jim. So she is the intermediary. Because Alice can speak both languages, they can communicate to one another through Alice, forming a new network. The first iteration of the internet was within the ARPANET project in the late 1960s. This project was founded by the United States Defense Department and was the first documented network in action. However, it wasn't until 1989 when the internet as we know it was invented by Tim Berners-Lee by the creation of the World Wide Web. It wasn't until this point that the internet started to be used as a repository for sorting and sharing information, just like it is today. Let's relate Alice's network of friends to computing devices. The internet looks like a much larger version of this sort of diagram. So you have the internet, network 1, network 2, network 3. Or if you want to think about it, is the 2 friends that Alice is introducing, Alice and the other 2 friends that she is communicating the other language. As previously stated, the internet is made up of many small networks all joined together. These small networks are called private networks, where networks connecting these small networks are called public networks. or the internet. So to recap, a network can be a network can be one of two types: a private network or a public network. Devices will use a set of labels to identify themselves on a network, which we will come onto in the task below. Answer the question below. Who invented the World Wide Web? The answer is Tim Berners-Lee. Now you're set to move on to the next module. Furthermore, now moving on to task 4, ping ICMP. Ping is one of the most fundamental network tools available to use. Ping uses ICMP, Internet Control Message Protocol, packets to determine the performance of a connection between devices. For example, if the connection exists or is reliable, the time taken for ICMP packets traveling between devices is measured by ping, such as in the screenshot below. This measuring is done using... Sorry about that, my dog was using a chew toy. This measuring tool is done using ICMP echo packets and then ICMP echo reply from the target device. Ping can be performed against a device on a network, such as your home network or resources like a website. This tool can be easily used and comes installed on operating systems, such as Linux and Windows. The syntax to do a simple ping is ping IP address or website URL. Let's see this in action in the screenshot below. And it is just like it said, ping and then the IP address. Here we are pinging a device that has the private address of 192.168.1.254. Ping performs that we have a sent 6 ICMP packets, all of which were received with an average time of 4.16 seconds. Now you're going to do the same thing to ping the address of 8.8.8.8.8 on the deployable website. In this task, the pinging the correct address will reveal a flag to answer the following questions below. So we're gonna go ahead and get this machine started. So now we're just gonna put 8.8.8. We're gonna send the ping. And notice it's already integrated the ping there. So you're just putting 8.8.8. And here you have the flag that goes here. So we're gonna go for the first question. What protocol does ping use? And that is ICMP. And next one is, what is the syntax to ping 10.10.10.10? And that is, you have to put the word ping first and then the 10.10.10.10. And there you have it. That's pretty much it for this lab. Furthermore, now moving on to task 4, ping ICMP. Ping is one of the most fundamental network tools available to use. Ping uses ICMP, Internet Control Message Protocol, packets to determine the performance of a connection between devices. For example, if the connection exists or is reliable, the time taken for ICMP packets traveling between devices is measured by ping, such as in the screenshot below. This measuring is done using... Sorry about that, my dog was using a chew toy. This measuring tool is done using ICMP echo packets and then ICMP echo reply from the target device. Ping can be performed against a device on a network, such as your home network or resources like a website. This tool can be easily used and comes installed on operating systems, such as Linux and Windows. The syntax to do a simple ping is ping IP address or website URL. Let's see this in action in the screenshot below. And it is just like it said, ping and then the IP address. Here we are pinging a device that has the private address of 192.168.1.254. Ping performs that we have a sent six ICMP packets, all of which were received with an average time of 4.16 seconds. Now you're going to do the same thing to ping the address of 8.8.8.8.8 on the deployable website. In this task, the pinging the correct address will reveal a flag to answer the following questions below. So we're gonna go ahead and get this machine started. So now we're just gonna put 8.8.8. We're gonna send the ping. And notice it's already integrated the ping there. So you're just putting 8.8.8. And here you have the flag that goes here. So we're gonna go for the first question. What protocol does ping use? And that is ICMP. And next one is, what is the syntax to ping 10.10.10.10? And that is, you have to put the word ping first and then the 10.10.10.10. And there you have it. That's pretty much it for this lab. Task 3. Identifying devices on a network. To communicate and maintain order, devices must be both identifying and identifiable on the network. What use is it if you don't know whom you are talking to at the end of the day? Devices on the network are very similar to humans in the fact that we have two ways of being identified: our name and our fingerprints. Now we can change our name through deed poll, but we can't, however, change our fingerprints. Every human has an individual set of fingerprints, which means that even if they change their name, there is still an identity behind it. Devices have the same thing. Two means of identification, with one being permeable. These are an IP address and a media access control, or MAC address. Think of this as being similar to a serial number. An IP address. Briefly, an IP address or Internet Protocol address can be used as a way of identifying a host on a network for a period of time, where the IP address can then be associated with another device without the IP address changing. First, let's split up precisely what an IP address is in the diagram below. So right here you have your first octet, your second octet, your third, and going all the way to fourth. An IP address is a set of numbers that are divided into 4 octets. The value of each octet will summarize to be the IP address of the device on the network. And this number is calculated through a technique known as an IP addressing and subnetting, but that is for another day. What's important to understand here is that an IP address can change from device to device, but cannot be actively simultaneously more than once within the same network. IP addresses follow a set of standards known as protocols. These protocols are the backbone of networking and force many devices to communicate in the same language, which is sometimes that we'll come onto another time. However, we should recall that devices can be on both private and public networks. Depending on where they are will determine what type of IP address they have: a public or private IP address. A public address is used to identify the device on the internet, whereas a private address is used to identify a device amongst other devices. Take the table and screenshot below as an example. Here we have 2 devices on a private network. So you have your device's name right here, your IP addresses, and your IP addresses type, and it's showing you private, public, a mixture of these. So just take a moment and to really get to understand what's the difference that we have here. I already see a lot of differences that they both have in between each other. Moving on. These two devices will be able to use their private IP addresses to communicate with each other. However, any data sent to the internet from either of these devices will be identified by the public IP address. Public IP addresses are given by your internet service provider, or ISP, at a monthly fee. Your bill. As more and more devices become connected, it's becoming increasingly harder to get public addresses that isn't already in use. For example, Cisco, an industry giant in the world of networking, estimates that there would be approximately 50 billion devices connected on the internet by the end of 2021. Cisco 2021 enter IP address version. So far, we have only discussed one version of Internet Protocol addressing scheme known as IPv4, which uses a numbering system of 2 and 32 IP addresses, 4.29 billion. So you can see why there's such a shortage. IPv6 is a new iteration of the Internet Protocol addressing scheme. To help tackle this issue, although it is seemingly more daunting, it boasts a few benefits. Supports up to 2 and 128 of IP addresses, 340 trillion plus, resolving the issue faced with IPv4. More efficient due to new methodologies. The screenshot below compares both IPv6 and IPv4 addresses. And here's the screenshot that it is referring to. So you could tell that IPv6 is much bigger than IPv4. Moving on to MAC addresses. Devices on a network will have a physical network interface, which is a microchip board found on the device's motherboard. This network interface is assigned a unique address at the factory it was built at, called a MAC, Media Access Control Address. The MAC address is a 12-character hexadecimal number, a base 16 numbering system used in computing to represent numbers split into two and separated by a colon. These colons are considered separators. For example, A4 colon C3 colon F0 colon 85 colon AC colon 2D. The first 6 characters represents the company that made the network interface, and the last 6 is a unique number. So right here we're gonna see what's going on. So we have a vendor who built the interface network. In this instance, Intel. So that's how you would know. And then you have a unique address of the network interface. So its own unique address that it gave itself. However, an interesting thing with a MAC address is that they can be faked or spoofed in a process known as spoofing. This spoofing occurs when network devices pretend to identify as another using its MAC address. When this occurs, it can often break poorly implemented security designs that assume that devices talking on a network are trustworthy. Take the following scenario. A firewall is configured to allow any communication going to and from the MAC address of the administrator. If a device were to pretend or spoof this MAC address, the firewall would think that it is receiving communication from the administrator when it isn't. Places such as cafes, coffee shops, and hotels alike often use MAC addresses controlled when using their guest or public Wi-Fi. This configuration could offer better services, faster connection for a price if you're willing to pay the fee per device. The interactive lab attached to this task has been made to replicate this scenario. Practical. The interactive lab's simulate a hotel Wi-Fi network where you have to pay for this service. You'll note that the router is allowing Bob packets blue to the TryHackMe website and is placing them in the bin. But Alice's packets green are going through fine because she has paid for Wi-Fi. Try changing back Bob's MAC address to do the same as Alice's to see what happens. Deploy the interactive lab and proceed to answer the following questions below. So let's go ahead and get this challenge started. It's relatively easy. So here you have Alice's her message going through, and now let's check out Bob with his MAC address. As you could see, it's going to the trash. Let's try it one more time. As you can see, it's all going to the trash. However, now we're going to change this. And as you can see, once we changed the MAC address to the same one as Alice, now it is going through and we have our flag. But moving on, what does the term IP stand for? And that is Internet Protocol. The second question is what is each section of an IP address called? And that's an octet. How many sections in digits does an IP address have? And that is 4. What does the term MAC stand for? That is Media Access Control. And here, just copy and paste the flag that we captured, and you're all set to move on to the next chapter. To task 5, continue your learning Intro to LAN. Continue your learning by joining the Intro to LAN room. So for the answer to the question below is no answer needed. You just put complete, and we're gonna move on to the next networking challenge. Thank you for watching.